We're surrounded by all this tech that just feels like magic, right? Apps, websites, all the software that runs our world. But here's the thing, it's not magic at all. It's actually a really deliberate, kind of fascinating process. So today, we're going to pull back that curtain and look at the secret recipe, system analysis and design. This is how a simple idea becomes that powerful tool you use every single day.
I mean, think about it. The last app you opened on your phone, it probably just worked, right? It felt seamless, intuitive. But how did it get that way? Where did it come from? Well, it started as a solution to a problem. Maybe just a little idea sketched on a napkin. And that whole journey, from that first little spark to the polished thing right there in your hand, that's exactly what we're going to break down.
All right, so every great story needs a hero, right? And in the story of how software gets made, our hero is the system analyst. I want you to think of them as part detective, part translator, and part master planner, all rolled into one person. They're the absolutely critical link between, a real-world business problem and the high-tech solution. And the key word there is bridge. See, a system analyst's job isn't just to write code. Not at all. Their main gig is to diagnose business problems and then figure out how tech can fix them. They have to listen, really listen to what people need, and then decide how a new system can help. Or, and this is important, if a new system is even the right answer in the first place. So yeah, they're problem solvers first, tech experts second.
So what does it take to be a great analyst? Well, it's not just about knowing a bunch of programming languages. It's a whole mix of skills. You've got to be a creative problem solver for sure. You need to be an amazing communicator, someone who can talk to the big bosses and the people who actually use the software. And you need empathy to really get what people are going through. And of course, being ethical and a self-starter, that's absolutely non-negotiable when you're in charge of these huge, expensive projects.
Yeah, because they're that central person, the bridge. An analyst ends up wearing a ton of different hats. Seriously, one minute, you're an educator, helping people feel comfortable with new tech that might seem scary. The next, you're basically a salesperson, convincing managers that this project is worth the money. And in the end, you become an agent of change, helping a whole company learn a new way to do things.
Okay, so we've met the who in our story, the system analyst. Now let's talk about the how. I mean, even the most brilliant analyst can't just wing it. They need a plan, a roadmap. And in the world of system development, that master plan has a name, the System Development Lifecycle, or SDLC for short. And believe me, you need that roadmap. Without one, any project can just completely fall apart. We're talking budgets getting blown out of the water, deadlines flying by, and the final product being something nobody actually wants or can use. It's just chaos. That's why having a method is so critical. The SDLC gives you that structure. It turns all that potential chaos into an orderly, predictable process.
And here it is. This is what that roadmap looks like. You can see it's a cycle, right? It starts with an idea, then moves through planning, building, and finally ends with putting it out there and keeping it running for the long haul. Each part flows right into the next, which is super important for making sure nothing gets missed and every single step is done on purpose. So let's jump in at the very beginning.
All right, our journey starts at square one, asking the most important questions first. This is the analysis and feasibility phase. You can think of it as laying the foundation for the entire house. And if you get this part wrong, well, the whole project is basically doomed from the start. No pressure, right?
And really, it all boils down to one huge question. Is this project even a good idea? That's what the feasibility study is all about. It's the project's first major checkpoint, the big go or no-go decision. We've got to figure out, can we even build this thing? Will it make us money? And maybe most importantly, will people actually use it out in the real world? So, to answer that big, hairy question, the feasibility study gets broken down into three main parts. First up, technical feasibility. This is the can we actually build it check. Do we have the right tech, the right people with the right skills? Second, economic feasibility. Pretty straightforward. Does this make financial sense? Will we get more out of it than we put in? And finally, and this one's so important, operational feasibility. Will people actually use it? Will it fit into how they already do their jobs? And hey, this isn't just some wild guess. Let's take economic feasibility, for example. A really common way to figure this out is the time to payback calculation. So check this out. Let's say the project costs $110,000 upfront. Then we just track the money it brings in each year. So in year one, it makes $20,000. Year two, $40,000. Year three, $60,000. You add that up, and boom, that's $120,000. So sometime during year three, the project has officially paid for itself.
It's a simple little calculation, but it gives the people in charge a real number to look at. It turns a gut feeling into a solid business case.
All right, so we got the green light. The project is officially feasible. Now the real detective work starts. This is the analysis phase. It's all about digging deep, gathering facts, talking to everyone involved, and figuring out the exact requirements for what this new system needs to do. In one of the biggest tools in the toolbox for this phase, the good old-fashioned interview. I mean, the advantages are huge. You get to build a real connection with people, you can ask follow-up questions, you can even read body language to see what they're really thinking. But there's a flip side. Interviews are super time-consuming and can be expensive. Plus, a lot of its success really depends on how good the analyst is at interviewing. It's this constant balancing act, choosing the right tool for the job.
Okay, so we finished our investigation. We have a super deep understanding of the problem and exactly what the solution needs to accomplish. Now we get to switch gears. We're moving out of the world of ideas and requirements and into the world of actually creating something, starting with the design phase.
So, if analysis was all about being a detective, you can think of the design phase as being the architect. This is where the analyst and designers draw up the detailed blueprints for the entire system. I mean, everything. What will the screens actually look like? How is the database going to be structured? What are all the little rules and bits of logic? Every single detail gets mapped out before anyone even thinks about writing a line of code.
And once those blueprints are signed off on, it's time to bring in the construction crew. This is where the programmers and developers step in. They take those super detailed designs and start translating them into a real working system. But look, just building it is only half the battle. Now we've got to make absolutely certain it was built correctly. And that, of course, is where testing comes in. And I want to be clear, this is so much more than just hunting for bugs. It's about going back to that original list of requirements and verifying that the thing we built does everything it's supposed to do. And testing happens on all different levels. You test the tiny little pieces, that's called unit testing, and then you test how all those pieces work together as one big seamless system. Okay, the system is built, it's been tested, it is ready to go. We are now at the most exciting and, let's be honest, probably the most nerve-wracking part of the whole journey, going live. This is the implementation phase, where the new system finally gets rolled out to the people who are going to use it.
But going live isn't as simple as just flipping a switch. Oh no. The analyst has to pick the right strategy, and there are a few options. You could go parallel, where you run both the old and the new systems at the same time. It's super safe because you have a fallback, but it's also really expensive. Or you could do a phased approach, introducing the new system one piece at a time. A pilot is another option. You try it out in just one department first to work out any bugs. And then there's the direct cutover, the big bang. You just turn the old one off and the new one on. It's definitely the riskiest, but it's also the fastest and cheapest. Every single option is a trade-off between risk, cost, and speed.
Now, you might think that once the system is live, the work is done, but not even close. Software isn't something you just build and forget about. It's more like a living thing that needs to be taken care of. The maintenance phase is all about constantly monitoring, evaluating, and tweaking the system. Yeah, that means fixing bugs, but it also means adapting to new business needs and just generally making things better over time, so it keeps delivering value for years and years.
And when you step back and look at it, this whole journey, from that very first idea all the way to long-term maintenance, it all comes back to this one thing. It was never really just about the technology. It's about making improvements that support real people and help a business run better. That's the real goal, right there.
So there you have it. The secret recipe isn't magic after all. It's a structured, careful journey. It's having a skilled analyst to guide the project along a proven roadmap. This whole process, the SDLC, is the framework that takes a promising idea and turns it into a powerful working system. And frankly, it's what separates the projects that actually succeed from the ones that just end in chaos.
So now that you've seen how it all works, I'm going to leave you with a question. Just look around at the tech you use every day. Think about that one app that always drives you crazy, or that clunky website, or that completely inefficient process you have to deal with at work. What's the outdated system in your life that's just waiting for a little analysis and a brilliant redesign?